8-7 Day 2, we're going to review what we looked at yesterday, vertical asymptotes and holes, and also take a look at something called the horizontal asymptotes. For the warm-up, find and list the vertical asymptotes and holes of the rational function. Try graphing the function to check your answer. So remember, when you're finding vertical asymptotes and holes, the first step is to factor. The top is already factored, and the bottom is pretty easy to factor if you notice that it's difference of squares. We have x squared minus 9, and that would factor to x plus 3, x minus 3. A whole is when you have the same factor in the numerator and the denominator, and it's what makes that factor 0. So the whole would make x plus 3 equals 0, and that would mean that there is a whole at negative 3. The vertical asymptote is what makes the remaining factors in the numerator 0. So we have x minus 3. What makes that equal 0? X equals 3. So here would be our vertical asymptote, and at the negative 3 there would be a hole in the graph. You can try graphing that to see what it looks like if I pull up a graph page here. And type in our function. So the top is x plus 3 times x minus 1, and the bottom was the x squared minus 9. Oops, I want that on the inside. And you can see that there's that vertical asymptote at 3, and there would be a hole at negative 3, so if we zoomed in we'd be able to see the hole. So there's the function. Today we're going to look at the horizontal asymptotes. So you can see that this function does have a horizontal asymptote, and we have to figure out how we get that horizontal asymptote. So for horizontal asymptotes, look at what happens to y as x approaches infinity and negative infinity. So again, asymptotes, you'll see the graph start to level off. This graph has 2 of them. It appears that there's one horizontal asymptote. And the next question is it x equals or y equals? And horizontal asymptotes will be y equals. So it appears that there's a horizontal asymptote at y equals 1, and there's another one at y equals negative 1. So we're going to look for those today and see if we can find a pattern in finding those just by looking at the function. So here's the other way to find the horizontal asymptote. You can find the king of the top and divide that by the king of the bottom, the term with the highest exponent. So king of the top, we're looking for the term with the highest exponent. That would be 4x squared. King of the bottom would be the 2x squared. So we're going to divide those, and I'll set equal to y equals because I know that my horizontal asymptote will be y equals. And when we divide this, notice we can reduce this fraction. We have x squared on the top and x squared on the bottom. Those cancel. And we have 4 divided by 2. So the horizontal asymptote will be y equals 2 for this function. And we could type it in and see what that looks like. So let's try that. So again, the horizontal asymptote will be y equals 2. Let's plug that in.
Kara Mueller, please dial 6106. Kara Mueller, please dial 6106.
So on the top we have 4x squared minus 3x plus 1. And on the bottom we have 2x squared minus 1. So you can see this is a bunch of different asymptotes. We're just looking at the horizontal, and here's that horizontal asymptote at y equals 2. We can also see that there's 2 vertical ones if we were to factor the bottom and set it equal to 0. Okay, let's do a few more examples. So here's the next example. Find the horizontal asymptote of this function. Again, you take your king of the top, your highest exponent, divide by the king on the bottom. We have y equals x squared over x squared. So the horizontal asymptote will be y equals 1. this one, let's also take a look at what would the vertical asymptotes be. So to review from yesterday, so here's the horizontal asymptote, y equals 1. But to find the vertical asymptote, let's factor this. So if we use a box and circle for the top, that factors to x minus 3 over x plus 2. And on the bottom, that factors to x plus 1, x minus 1. And so if we take a look at the vertical asymptotes, what makes the bottom 0? It would be x equals negative 1 would make the first one factor 0, and x equals 1. So for this graph, we should have 3 asymptotes, a horizontal at 1, and 2 vertical at 1 and negative 1. So let's try typing that in and seeing what that looks like. Oops. Hold this up here. All right, so tab, let's arrow up, let's delete our previous function. And on the top, again, we have x squared minus x minus 6. And on the bottom, we have that all divided by parentheses x squared minus 1. And you can see that there's that horizontal asymptote at y equals 1, and there's a vertical at x equals 1 and x equals negative 1. Example 3. Find the horizontal asymptote of this one right here. Again, king of the hill, king of the top, king on the bottom. Again, look for the highest exponent. It might not be in general form, which we're used to seeing, so this one's kind of hidden over here at the bottom. And so we have y equals 2x squared over negative x squared. The x squareds cancel, so we have the horizontal asymptote at y equals negative 2. All right, so you can graph that. You can see what that looks like. Let's have you try one. So I'll give you a minute or so. See if you can find the horizontal asymptote of this function. Well, if you set the king of the top over the king on the bottom and divide, you're left with 3 over 5. So the horizontal asymptote would be at 3/5. Now the x squareds don't always cancel, so let's take a look at what happens when they don't. So this one right here, the king of the top is 2x, the king of the bottom is x squared. So when we cancel, we're going to get 2 over x. Now when you have an x left on the bottom, or a higher power of x left on the bottom, let's think about what the asymptote means. As x approaches infinity, as x gets bigger and bigger, think about what's happening to the fraction. 2 divided by a really big number will approach 0. So whenever you have a higher power on the bottom, so here x, if we would have had x over x squared or x over x to the third, anytime you have a higher power on the bottom, then the bottom gets bigger a lot faster than the top, and so then the asymptote will approach 0. So again, when you have a higher power of x on the bottom, the asymptote is y equals 0. So let's take a look at what this graph would look like if we were to put this in our graphing calculator. So that one was 2x divided by x squared minus 5x minus 3. And you can see that there would be, and I didn't use my parentheses right, a horizontal asymptote right here at y equals 0. Okay, so the next function, same thing happens. So you have y equals, here's the king of the top, king of the bottom. We have x over x squared. That's 1 over x. And as x gets really big, 1 divided by a really big number is 0. So we're going to say the horizontal asymptote is y equals 0. Last example, what happens if you have a higher power on the top? And so this one we have 3x to the third over x squared. And here is a case where the x doesn't cancel. And this will actually have an asymptote that's slanted. It'll be a line. So it's called a slant or oblique asymptote, and we're not going to worry about these. So if you get any on your assignment where there's a higher power on the top, then you can stop there, and you don't have to worry about then the horizontal asymptote. So in summary, if the highest power is the same, the asymptote is y equals the coefficient. So for example, if we had y over 3 x over 5, y equals 3x over 5x, it'd be y equals 3 over 5. If the highest power is on the bottom, the asymptote's y equals 0. So here are two examples of things that you'll see on your assignment. Find and list any vertical and horizontal asymptotes or holes. Sketching the asymptotes as dashed lines, sketch the function. You may use your graphing calculator to help. All right, so first step, let's do horizontal. Take a look at the king on the top and the king on the bottom. So we have a horizontal asymptote at y equals 1. Let's sketch that in with the dashed line. Okay, so there's our horizontal. And then we have, if we factor this, it's a different color. So for the vertical asymptotes, we have x to the third over, pull out an x squared minus 9. And for this one right here, if we factor the x squared minus 9, that's x times x plus 3 times x minus 3. So there's 3 vertical asymptotes. One at x equals 0, x equals negative 3, and x equals 3. So if we put those in, x equals 0, x equals 3, and x equals negative 3. And you could type this into your calculator to see how to sketch the function. And the last one, we have for the horizontal asymptotes, y equals 4 over x. Here, this is going to get really big really fast, so we say that there's a horizontal asymptote at y equals 0. The vertical asymptote is what makes the bottom 0. X equals 2 makes this 0. So here's x equals 2. And again, you can use your graphing calculator to sketch the function. We'll do this one. So it was 4 divided by x minus 2. And you can see our asymptotes are in there. You can sketch the function. So your assignment is to practice yesterday and today's skills of finding vertical and horizontal asymptotes, and also holes if there's any.